circuit to the positive end of that circuit or battery. Electrons carry a certain amount of potential energy, that's that stored up energy, because they're being held apart from the positive charges they are attracted to. So electrons bump into atoms in the conducting wire, transferring some of their energy to the electrons in the atom they bumped into. Some of that energy is transferred into heat and light, and this happens billions of times a second as the bumping in a wire is extremely fast. If an electron bumps into a neighboring electron, that bumping will cause the electron to lose energy as it's transferred to the next atom. The longer the wire in a circuit, the more bumping electrons will have to do to get from the negative end of the battery to the positive end. Each bump costs electrons some of their energy. The more bumping they do, the more energy they lose. So energy loss is equal to electrons slowing down. So as they lose energy, they actually slow down in that circuit. The slowing of electrons in a circuit is called resistance. That resistance allows for the electricity to be converted to other forms of energy. This slowing of electrons is called resistance. A resistor converts energy in electrons to other forms of energy, such as, heat. So where would we find electrons being converted into heat? Would be in something like a toaster, in an oven, in an incandescent light bulb. So the incandescent light bulbs are the old light bulbs that have that stereotypical look to them. I know some of them kind of look the same now, but they've got that base and then got the top. Sorry, my drawings are not so good, like this. And they're the ones that get really, really hot. So if you had an easy bake oven when you were younger, you actually would bake tiny cakes and cookies with one of these incandescent light bulbs. We're shying away from those light bulbs now because of the amount of heat that they give off. No one ever says, "Ooh, it's chilly in the house, turn on all the lights." So we don't use light bulbs for that heat, except in that case of that easy bake oven. So we've switched to more energy efficient forms of light that stay cool to the touch, so we're not using up extra energy as that heat when we're just looking for the light. Blow dryers, portable heaters would also convert that energy into heat. Light, so like a light bulb and a flashlight in your house, whatever else. Motion, something like a fan, a remote control car, something like that. And sound, like a radio. All appliances that use electricity use a resistor of some type to convert the electrical energy into those other forms of energy. The more resistance applied to a circuit by a resistor, the more energy is lost or transferred to other forms of energy from the electrons. The more energy transferred by electrons, the less energy they have driving them to the positive terminal. So that lowers the voltage in the circuit. This can be accommodated by increasing the current in the circuit, which in turn increases that voltage. Resistance is measured in a unit called ohms. And the symbol for ohms is this upside down kind of horseshoe, which is the Greek letter omega. So the formula for resistance, this is often called Ohm's law. So resistance is equal to voltage divided by current. Again, resistance is measured in a unit called ohms. Voltage is still measured in, the symbol for voltage is still measured in volts. Potential. Should be an I there. Still measured in volts, and current is, symbol for current still I, and it's measured in amperes. So resistance, symbol for resistance is R, measured in ohms. V, potential difference, measured in volts. I is still current, and that's measured in the unit called amperes. And again, this formula is also on your formula sheet. Oh, goodness. Again, when we're completing problems for resistance, we're going to write down what we know, determine and write the formula, solve for the correct variable, put in our known values, and then find an answer, write in our units, and put a box around it. Again, this is our third formula on our formula sheet. So for example, the resistance of a hot plate is equal to 40 ohms. So if I match up my symbols, ohms is resistance. So I put an R above that. How much current? Oh, current is I. I don't know, it's asking me how much. So I is equal to question mark. Does the plate carry when connected to a 120 volt source? So if I find V on my formula sheet, volts is a measure of that potential difference, or V. So I write down what I know. I know that V is 120 volts. I know that I'm trying to find I, so there's a question mark beside it, but I know resistance is 40 ohms. So I write my formula. Here's my triangle. Again, I cover up what I'm trying to find. I'm trying to find current. I'm left with V divided by R. So I filled it in my formula there. I write in my known values. I know that V is 120, R is 40. Type that in my calculator. I get 3. So current is equal to 3 what? 3 amps or amperes. So what I'd like you to do now is task 4 on page 19. And it's just 3 quick questions using that formula. Hope that's so task. Oh my goodness, use my finger. Oh, no, that doesn't like me. Task. Oh goodness. Okay, well, keep writing like this then. Task 4. And again, if you're having any trouble with the math here, make sure you're getting some help. If you want, we can set up some tutorial times where we log into Teams and set up a meeting, and I kind of walk you through the problems that you're having, or you walk me through by sharing your screen. Hope that's helpful. Have a great day.